Welcome to the webinar about structural simulation tools in Creo Parametric. During this webinar, we will cover quite a lot of tools within Creo Parametric, and the target is to see the differences and to answer your question about that. The agenda looks as the following. First, I'd like to introduce me and the company I'm working for, and then we'll see the various structural simulation tools in Creo Parametric, starting with the Simulate standalone app and so on, and ending with the newest product, the Creo Ansi Simulation in Creo 7.0.2.0. Okay, and of course, the most of the time we will see some live demos with the 4 products. Okay, and at the end or during the webinar, feel free to ask the questions via the question panel. Okay, me, Urs Simler, CAD simulation specialist working for GIA Informatik AG. Since 5 years I'm working in GIA before I spent 20 years at PTC. Here are the coordinates of my sales colleague, Daniel Losley. If you have any questions about sales topics, here you can find his coordinates. By the way, I also have a YouTube channel. Unfortunately, I didn't update it during the last half year, but after this webinar, I will perform some updates with tips and tricks and other webinars. Okay, who is the company, or which is the company I'm working for? This is GIA Informatik AG. Around 150 people are working for that company. We belong to a bigger company called Villa Martini, and our team are working with SAP solutions. We have some IT services, and around 10 people are working in the business with CAD, CAM, PLM software. And our target is to have some successful customers, so we want to do some implementation, support, trainings after we sold, let's say, the software. In the PLM environment, PTC is our main partner, but beside the PTC, we are also supporting solution from B&W, Software Factory, Elaborate, TechSoft, or CAESS. That are also companies which are working in the PTC Creo environment. Our offerings are the following. We are doing some training consulting, implementation with Creo Parametric and all, let's say, the tools in Creo Parametric. We also have big customers who are working with Creo Elements Direct. Beside that, we also did some implementation of Elements Direct with Windchill with 2 big customers. We can support you with MatCat, ThinkWorks, Navigate, and topology optimization from the company CAESS, electrical clearance and creepage analysis from Elaborate, and as I mentioned before, solutions from TechSoft, Software Factory, and B&W software. And if you need any education, we can support you with custom tailored workshops or standard workshops in our training center or at your premises. We're quite experienced. Okay, that's all about me and the company I'm working for. So today's topic is simulation or structural simulation tools in Creo Parametric. We have a nice bunch of tools, and about, let's say, 2 months or 1 month ago, a customer rang me up and asked me, hey, I got a message that Simulate will not be available anymore in Creo Parametric. And I told him that that's not true. Here we see the letter he got. And here it's mentioned, let's say, that standalone apps, which is called Creosimulate, will enter support with Creo 7.0, but this is, let's say, only the standalone app of Creo Direct, Render Studio, Creo Layout, and of course of Creosimulate. The standalone app was designed for people without any Creo Parametric license. Maybe as Creo Elements direct customer, they used these standalone apps, but this has no effect, let's say, this cancellation of the standalone app for Creosimulate as an extension in Creo Parametric. And also the Creo Elements direct customer, they have a Creo Parametric license. Unfortunately, the name of that license is Mechanica Foundation. So if you still use as Creo Elements direct customer, let's say the standalone app, you just have to switch to the PTC Creo Parametric Mechanica Foundation license, and then everything works as before. I would say it works better than before because, let's say, the interface between Elements Direct and Creo Parametric will be much better because we are using, let's say, the newer technology called ATB, Associative Topology Bus. I will show that later on in the live demonstration. So the direct interface, the push interface from Element Direct cannot be used anymore in the future, and therefore we'll just work in Creo Parametric, and with the help of the ATB we are going to import the so-called package file from Elements Direct. Okay, then PTC, Creo Parametric customer, they quite often buy a so-called Design Essential package. These packages are 2 years old around. And in that Design Essential package, this package is available until further notice. In this package, you have a small Creo Simulation Elite package, and with that you can do, let's say, only linear static analysis for parts and assemblies without, let's say, contacts and so on. You can do, let's say, that kind of simulation we see here on the screen. I will show that also later in the live demonstration. So this is a newer package available, let's say, for smaller and medium customers. Then the other tool we can use, it's called PTC Creo Simulation Extension. This is available until, I don't know. And with that package, you can do linear static analysis for parts and assemblies, modal, buckling, and steady state thermal analysis. Contacts are available, and also idealization like beams, like shells are available, and as I mentioned, thermal analysis is also possible with that, let's say, basic package of Creo Simulation Extension. In the older days, this was called the Mechanica extension. Okay, and let's say the big thing of the Mechanica or Creo Simulation extension is the Advanced Simulation extension. In that package, you have, let's say, all non-linearities like contacts, large deflections, non-linear material behavior. You can also perform vibration analysis, and on the thermal side there are transient thermal analysis are available. Okay, we'll see later on that example here. Okay, And around 2.5 years ago, in summer 2018, the CEO of PTC and Ansys made during a golf session, and they decided they want to work together, so they announced a partnership between PTC and Creo, and their target is that they want to democratize the simulation in product design. So there is a big value of doing more and more and more simulation, testing. We know that during that strange times with Corona, and with the help of that partnership, we should have, let's say, easier to use simulation tools within Creo Parametric, and therefore we can see the Creosimulation live package in the Ansys environment. It's called Discovery Live package. We can see that package starting from Creo 4.0, and this is really an interesting package because it's GPU based, so it's analyzing on the graphic card. You need a special graphic card, and with that help, with the basic package, you can do some linear static analysis of parts and also modal and buckling. This is not true. Sorry, this is wrong. Modal and steady state thermal analysis. In addition to that, there is also a package where you can do some CFD analysis. And this technology is really, I would say, fast and furious. It's incredible fast, and yes, you see, let's say, the changes during a topology change or geometry change within seconds. And I would really say it's it's live simulation. Okay, and starting now in Creo 7.0.2.0, we have another integration of a Ansys product. This product is called Creo Anti-Simulation. Right now we can do some linear static analysis for parts and assemblies. We can do some modal analysis. Buckling is not available right now, and we can do also some steady state thermal analysis right now in that version. Non-linear capabilities are planned in further versions of Creo Parametric, and the technology behind that Ansi simulation is called the Ansys AIM technology. It's, let's say, standard H element technology of Ansys, and we'll see here, let's say, the first step of the integration in Creo Parametric. This will also be available starting from 7.0.2.0. Okay. That's more or less the theoretical part of that one. Now we're going to the demo part, and we'll do here first some demos starting in Creo Elements Direct Solid Designer. We'll see here, let's say, the interface, the new one between that and the Mechanica Foundation license. And then we'll see also, let's say, some basic simulation extension examples and advanced simulation examples. Then we're going for Creosimulation Live, fast and furious. I hope it will work on my machine because I have a non-certificated graphic card with only 1 gigabyte of GPU RAM, and recommendation from PTC is 4 gigabyte. Okay, and at the end we'll see the new integration of Ansi Simulation with the AIM technology. Okay, let's go for Creo Elements Direct. In the early days it was called Solid Designer. In Europe there are quite a lot of Solid Designer customers, and they want to do also some simulation with, let's say, Creosimulate technology. And in the earlier days they were using here under modules, they were using this application interface for Creosimulate. So if I click on that guy here you'll get an additional tab, okay? And in that tab they used here, let's say, this push interface. This will not be available anymore in Creo Parametric or Creosimulate standalone app 8.0. So this just works until 7.0 with Creosimulate standalone app. Okay, but I will show you, let's say, the new technology, which is much better, because here we just can say, okay, I want to save that model. Going here for save, and I want to save that model here by double clicking as a so-called package file. I call that live. Okay, this is the format of Elements Direct, and now I'm going here for Creo Parametric. Imagine we have the Mechanica Foundation license. With that license you can do some basic modeling and importing some components and nothing else more. There is no, let's say, surface or that kind of stuff available. And here we just can go for open, and we're setting the type to all files, and we can import this package file. The newest converter will be used, and this converter, let's say, has a nice capability. The quality is much better. Do not forget to activate the ATB, Associative Topology bus, and I would also recommend to use some templates. And then let's say this geometry will be imported, and because I activated the ATB, it will be connected, still be connected to the solid designer solution. Now we use here the path to start Creosimulate. In the most cases of the Element Direct customer, it's the advanced simulate they have available. And I will show here, let's say, a simulation which can be also performed from a customer which has the Creosimulate Elite license. So I have an assembly, and in that assembly I'm going in and I say, okay, I want to constrain it here. And in that assembly I'm going for that surface, and I want to push that surface with a force of 50 newtons in Y direction. When I'm importing that component, one material will be assigned, and here you can also bring in additional materials. I'm taking aluminium, I'm taking a copper, and I'm taking a steel, okay, to my simulation, and I'm assigning here aluminium to that component, copper to that component here, and let's take steel to those two components here. And so my, let's say, structural simulation is ready to take off, to start here. And with the Elite functionality, only new static or static analyses are available. I call it here as the, let's say, Elite. Okay. And by clicking on the green flag, the analysis will be started, and here I can see the status of that analysis. It will be meshed with P elements and with single pass adaptive in the region where needed. Let's say the mathematics is increased. Okay, we see here the results with the help of templates. We can have here a look at the results, and of course these results, you can spin them around. You can maybe double click them to see the behavior. You can see deflections and so on. Okay, now we are going in that example for a higher version of the license. We say, okay, now we want to create a analysis eigenvalue analysis, modal analysis here. This is available with the, let's say, standard Simulate license. Just can do here eigenvalue. Okay. And I want to analyze 4 modes. Okay. Clicking here again, start, it starts. And of course, meshing was already done. And now we see the behavior, and as a result, we're getting the eigenmodes. Okay, we'll see here that are the frequencies of the eigenmodes. And in the post-processor, I'm going to the post-processor, let's say by hand, and I'm going to show here an animation. Okay, this is the first eigenmode. Okay, by copying that one, I can see the second eigenmode. Copying again, the third. Okay, and copying again, the fourth. By holding down the Shift button, I can select all the result windows and spin them around. Okay, now my boss is coming and asking me, oh, we have to change something here. He wants to fill, let's say, that gap, and he wants to see how the eigenvalues are increased. I tell him, oh, I modeled that in Elements Direct. This is no Creo Parametric. Oh, no, that's no problem. So just going out of the post-processor, I'm going here back for the, let's say, Creo Parametric modeling mode, and I will open Elements Direct again. And here in Elements Direct, I'm activating, let's say, the space aluminium component. I'm selecting that surface, and with the right mouse button I can do some 3D dragging, and I'm using the options here with 2 points, maybe from here to here. I want to have 75 millimeters. Okay, this guy is moved, and now I'm saving the model again. So I'm double clicking that model should be saved again with this live package here. Okay, it will be overwritten. So now on my hard disk there is a new package file, and with the help of the ATB I can go in here and ask for the status. Parametric tells me there is a new status, and I can do here, right mouse button, ATB, I can do an update. And of course in that region the geometry changes, and therefore I just can enter Simulate again. Going for the analysis, maybe copying that analysis and starting that analysis, and within 10 seconds or 20 seconds I'm getting the new answer. Maybe I want to see the influence on the second eigenvalue, therefore I'm going for that one. I want to see, let's say, the second eigenvalue deformed, transparency, animated. Okay, that one here. We see it's at 128 hertz, and by copying then I want to see now, let's say, the results of the new analysis, and we see this is 141 hertz. So we see, okay, the mode was increased by about 10%. Okay, so it's quite easy to, let's say, analyze the changes of Creo Elements Direct also in Creo Parametric. Okay, let's go now for a more advanced example. Therefore, I'm changing my working directory to that guy here. Maybe you already saw that clip simulation on YouTube. but I think it's quite an interesting example. So we have here a plastic clip, looks like that here. And of course, because I want to perform a non-linear analysis, I'm using, let's say, the symmetric behavior of my component. I was doing a cut within the part. Do not cut in assembly mode when you deal later on with Simulate. It works, but it takes you much more time to set up the models. And now we're going for the simulation app again. Okay, here we can see, let's say, the already defined simulation model. It takes about 15 minutes to set it up from scratch, so I will just explain it here. Let's go for that mode. Let's say this is a mirror symmetric constraint in that direction. This is in the other direction, the mirror symmetric constraint. This is, let's say, I'm holding my clip in that direction, and let's say on that constraint here, I also did, let's say, a measure. I'm measuring the force there. See here, this is the force. So it's a measure I created here. Okay, and here in that area I did, let's say, the mirror symmetric for the tube, and this one is the interesting one. I said, okay, those two surfaces, they will be pushed in that direction by 17.6 millimeters. That's the distance between that edge here and that edge here. So let's say the clip will be forced to clip in. The tube will be forced to clip in. Okay, this is that constraint. In the material environment, I did also some special thing for the plastic component. I'm using here the elastoplastic stress strain behavior, and I defined, let's say, the material behavior with the table with about 6 rows. I created here the behavior, and now I have the nonlinear coefficients here with that material law, and these coefficients will be used for the nonlinear simulation. Then I did a connection here, a contact between that surface and that surface, and between that surfaces we have a coefficient of friction of that two. And then I did some special meshing, because later on I want to do nonlinear behavior with a lot of steps, and therefore I want to have an efficient model with nice meshes in order to deal later on, let's say, with a quick check analysis. Therefore I did some mesh refinements here in that area. As a first thing, I did here some brick elements of this analytical geometry of the tube. Okay, and I was doing a mesh refinement on the fingertip of my clip of 1 millimeter. Then here on that surface of 2 millimeters, and for the whole part, for the clip part, 4 millimeters. That ends, let's say, with a mesh as shown on the screen. Okay, on the left side, analytical brick elements, and on the right side, nice tetraeders, which give very, very good results. And later on, maybe for an additional diagram here, I defined an additional measure. I'm just measuring, let's say, the absolute value of let's say, that movement here of that point. Okay, and as a last thing here, I defined here the analysis, the nonlinear analysis. I'm using here quick check. That means polynomial degree of 3 because I created nice elements. And I want to deal here, we see that in the output, I want to deal with 41 steps during one, let's say this is the time during 1 second. And in that area, I brought in, let's say, a nice function with that 3 values over the time. This is the multiplication factor of my constraint here for that movement. I can do here, let's say, this function. Okay, we see that in the graph. And therefore it means, okay, here I set it up the multiplication factor to 1. So it's moving that guy, 17.6 millimeter. And then my function is going back to 0. So let's say the tube will be moved backwards. Okay, that's all behind that, let's say, special behavior. Then I run the analysis. The analysis takes a little bit longer, takes about 2,500 seconds. That's 40 minutes. And after 40 minutes, we are getting here the following results. Okay, this is the behavior of my clip here. Okay, we can see that clipping in, clipping out of the tube. And if needed, we can also have, let's say, the behavior, the force over the movement of the tube itself. So this is a really nice integrated advanced simulation of Creo Parametric. Now we're going for the next step. I hope this is working for Creosimulation live. So I'm changing again the working directory, and in that working directory here I have a quite complicated geometry. Well, now I'm shading it, and we can see it a little better. Okay, when you see that one and you say, okay, I want to do some simulation with that model, then it takes half an hour or even more, or you have a meshing problem. Not with the live simulation capability of Creo Simulation Live. I'm now entering Creosimulation Live. It's taking a while because the libraries are loaded of the Creosimulation Live technology. I hope it works. Yes. No. In case of emergency, I have a movie to show it, but I want to show it live. But it's taking a long time to load the libraries because really I have a very big 5-year-old graphic card. Now I'm entered Creosimulation Live, and here I have capabilities to do with the basic license, structural, thermal and modal analysis. With additional license, fluid analysis is also available. I'm setting up here some constraints. By default, let's say the structural analysis is activated. Okay, this is holding my component, and now I'm going for a force load on that surface. Hold down Control key, and on that surface I want to push in Z direction. Let's do 5,000 newtons. Okay, all the components have already assigned some material here, aluminium, and then I can click on that one. And now with the help of the graphic card, let's say the voxels will give me, let's say, the result. So it's like pixels on pictures, 2D pictures there. The 3D model will be filled with voxels, and then let's say the analysis will be performed. Here we see, okay, the von Mises stress of that guy. I can also go in here and do, let's say, some easy modification of the stresses here. Of course, I can see also deformation, that kind of stuff. I can animate that guy here and so on. So it's really fast and furious. And here in that area, I do not do that. You can also improve if you have enough GPU RAM, you can improve the quality. It's not possible here, let's say, to do some really detailed stress behavior in radius, but you're getting a very good feeling when you change something, because after 2 or 10 seconds you see the new behavior on such a complicated geometry. I'm doing now an additional modal analysis. So this is activated. I'm doing here again the same constraints, okay, on that holes here. Okay, and I'm running the analysis again. So again now, okay, that was the crash I was doing here. So I created here the movie. Now I'm creating here again, let's say this these constraints, and now I'm doing here the analysis, and the modal analysis will now be performed. It was done on the same laptop here with the same graphic card. Okay, now we see the results. The first mode can be seen at 1500 Hertz. Of course, we can animate that one. And now we can also see other modes here. I'm switching to the third one, 1600 Hertz, the fifth one, 2050 Hertz. And it's really incredible fast. You can do modification within the model, and within seconds you see the new behavior. Now I'm creating a new thermal analysis. All the components, they have, let's say, already a alpha coefficient, and now I'm creating here in the middle a heat load of 1.5 kilowatts. And again, I'm pushing the button, let's simulate it, and within 5 seconds we'll see the temperature behavior of that component. And we can see, okay, the temperature are reaching around, let's wait another second, 250 degrees. Now I'm adding, let's say, an additional heat load on that bearing, bringing in a heat load of 0.5 kilowatts. Okay, and starting the analysis again, and of course I'm getting, let's say, a new temperature distribution, and let's say the temperature will be increased from 250 to 300 degrees. Really, I can't believe that we can do simulation so fast. Okay, let's go for the next stuff here. In the next stuff, I want to show you the new capability of Creo Anti Simulation. This is with traditional H element technology. Therefore, I'm opening this little assembly here, and I want to create with the AIM technology. I want to create here a new simulation. Therefore, I'm going here for the Ansi Simulation. In the Ansi Simulation here, we can also do some constraining it here. You can work also with the mini toolbar, doing here a cylindrical constraint, doing here a moment load in X direction. I want to do 50 Newton meters. Okay, like that. And now I'm going for the Refine Model tab, and I just want to show you, let's say, the mesh Ansi Simulation is creating. Here you can, let's say, set up the mesh behavior, global mesh behavior, and here we do later on some local mesh refinement. I'm just meshing, let's say, with the default settings, and here we are getting the so-called process advisor. Okay, where we can see some information. Come on. Where we can see some information about the meshing behavior. Come on, more info. Here it's done. Yes, great. And here we can see, let's say, the mesh, which will be used, let's say, default mesh, which will be used for that simulation. It's a typical H mesh. Now in that Ansi simulation, I can run that one. So the solver starts right now. Unfortunately, it will not work because I forgot to assign some material. Here, run failed. More info. Okay, now it failed because I didn't do here any connection between those guys. I forgot that. Of course, it's live simulation. Here I want to do the special behavior. I want to create a joint from that surface to that surface. So again, from that surface, you see it's a live demonstration to that surface. I want to create a hinge. Okay, let's go for the next one. Create a hinge. So now it should work better to that surface. Okay. And let's go here to create the hinge again from that surface to that here. Okay. Nearly done. Hinge again from here to here. Okay. Now it's done, and now I'm going here for run it again. Okay. And I hope we see here the process advisor, which tells us now meshing is done, and now it's in progress, and I don't get any more mistakes. Okay, we have here also some information, what's the progress of the solving, what's the progress of the results. Okay, that should be done within, let's say, 1 minute. It's not fast and furious. This is not Creosimulation Live. This is traditional technology. We see now the results are available, the basic results, and we can have a look at the basic results here. This is, let's say, the stress behavior here of the whole component, that I can create here some specific results. I want to just see, let's say, the results on that component. Come on. Define results, okay, not of the assembly of that component, and here I want to see the first principle stresses. Okay, this is done. We see here we get a 2 new of them one, but they're outdated, and I have to, let's say, update the results here. Okay, and now by activating these advanced results, I can see the behavior of those components here. Of course, it's also, let's say, the mesh available. And here we can also switch to another mode, and we see, okay, this is too coarse to get any really nice results. We have around 300 megapascals, but when you change maybe that value to 200, then we see, okay, this result is really very, very coarse. That means, okay, we are just taking that study, and we are right mouse button, we are duplicating it. Okay, and we are activating that study, and we want to bring in, let's say, some additional mesh refinements. We're going here for mesh refinement, refine model tab, and we just want to influence the local mesh refinement. As a first thing, I'm going to select those two components. Come on. What is it doing right now? Oh, I pushed the wrong button. I went for generating mesh. Yes, I just want to do some local mesh controls. Here I have 0 inside, stupid guy. I'm going for 2 millimeters here, of course, and now I'm doing local mesh refinement on that guy here of 1.5 millimeters. Okay, and in the end an additional local mesh refinement on the surfaces. Here we have surface, this guy, that one, and that one here. Oh, I have to bring in a value of .5. Okay, now again, I'm starting the mesh, generating the mesh again, and now I should have a much better mesh to get meaningful results. Let's have a look here. Meshing process done. Okay. And now I'm able to display here the mesh. And we see, okay, in that area where we're expecting the big stresses here, we have a nice mesh. That means we can go here for that study, and we can run it again. This takes about 2 minutes, gives me time to go back to my slides. So we saw right now the live demos of the different products. And here I also added a function compare table. At the beginning we saw, let's say, PTC Creo Anti-Simulation, where we just could do some static analysis with parts and assemblies. Then we went in, we did some Eigenvalue modal analysis with extension. We also switched back to Elements Direct to update the geometry. Here in that extension we can do additionally modal analysis, buckling and steady state analysis, and I think also quite important here we have a linear contact. And then we did here PTC Advanced Creosimulation extension. Here we can do, let's say, more or less all with contacts, nonlinear material, large deflection analysis, and on the thermal side also with transient analysis. Then we went for Creosimulation Live, this guy here. We saw fast and furious technology with the help of voxels. Here we had a P elements. Here we have some voxels. We need a special graphic card. And we can do here also modal analysis, thermal analysis, but there is no contact available right now. Of course, here we have additional capabilities with fluids. This is also quite nice. So I would say this Creosimulation Live is somewhere between that and that. Okay, and now we are still running on our last version, let's take maybe the green color here, Creo Anti-Simulation. We have now version 7.0 with the first implementation, and of course in the further versions we'll get some additional functionality like nonlinear contact, nonlinear materials, and so on. Random vibration, basic drop tests might be available in Creo 9 Plus. So I would say it will take until Creo 10 or 11 that we'll see, let's say, this advanced functionality. Okay, let's go quick back for the simulation here. We see, okay, simulation is done. We just want to have a look at the stress result on that component. I'm bringing in also my mesh thing, and we see, okay, now it looks quite nice. If we are changing here the diagram, we see, okay, this is nice stress. It's around 320 megapascal. Okay, that brings me more or less to the end of the live presentations. As I told you, we'll get all that information this afternoon or tomorrow with an additional mail. If you have, let's say, also the need to do some workshops, to do some educational work, we can do that also online, especially with the simulation products. Is this quite easy because everybody knows the Creo Parametric interface or what else, and so it's quite easy to find the new functionalities. So you'll find here under that link, let's say the standard workshops, but we can also, let's say, perform workshops custom tailored for you online or at your premises. For that reason, contact me. You'll find, let's say, the standard workshops, and now we'll have, let's say, time for question and answer. Okay. One question is, how would you rate the stability of the measure in comparison to the standard Creosimulate measure? To be honest, I would say right now I didn't do that much, let's say, meshing tests with the Ansys measure. So far, I would say it doesn't seem to be that bad, and I hope that because that is Ansys, older Ansys technology, mature Ansys technology, that the measure is working okay. Of course, you have to check for interferences, you have to check for geometric inconsistency and that kind of stuff, but I really must have a look at it if it's a problem. The next questions. Do you know if there is a conversion path to move from Creosimulate standalone to extension? Let's say in the case of Creo Elements direct customers, the path is already available. If you check their licenses, there is always a so-called Mechanica Foundation license. This has nothing to do with simulation. Mechanica Foundation license, this is a, let's say, very basic Creo Parametric license, and then you can deal as I showed you in the first demonstration. If the customer really bought Creosimulate standalone app, I think you have to contact the PTC representative to answer that question. Okay, I'm waiting for some further question. I think nobody has additional questions. Seems to be everything clear. checking my watch, nearly perfect. 55 minutes and we're done, so that brings me to the end here. Oh, that was the slide for the questions. Okay, it brings me to the end. I'd like to thank you for your time. I hope it was worth to spend this time here with me. If you have further questions, feel free to contact me or Mr. Lowesley. And thanks again. Wish you a great day. Stay safe and healthy. Auf Wiedersehen.